Alright, we will now inspect one more motion problem, starting with step 1. Read the problem carefully. Jamie jogs and walks to school each day. They walk at a rate of 4 kilometers per hour. They jog at a rate of 8 kilometers per hour. Their trip is 6 kilometers long. So the distance from their home to their school is 6 kilometers. And if they make it in 1 hour, so they complete their trip in 1 hour, how far did they jog? So we start with our given, we read, we carefully pick out the information. We are given that the jogging rate, or jog speed if you prefer, is 8 kilometers per hour. The walking speed is 4 kilometers per hour. The distance, total distance walked, or ran, or both, better way to say that, distance traveled, is 6 kilometers, and the time it took was 1 hour. What we are asked to find is the distance jogged. I'm going to call that J. Now, it might be of interest to us to also have a variable for the distance walked. I'll call that W, but what we're really interested in is J. So we notice that this is another motion problem, another physics problem, so we're probably going to be using D as RT again, so we'll just write that down as a formula for us to use. I noticed we were given a distance here, and also a time. So we might need this solved for T as well. I can move the R over via division. And that is how we would rewrite that to solve for T. Step 2 asks us to translate all of this information into math. Well, we know that the distance traveled, so 6 kilometers, how far we traveled. That's how far we jogged and how far we walked. So we jogged some distance and walked some distance. First equation. Second equation. What else do we know? We know the total time. So we know total distance and total time. Total time was 1 hour. And we know that this is D divided by R, but we have 2. Right? We have some distance that we jogged and some distance that we walked, so this must be the sum of those 2. So we jogged some distance. The rate at which we jogged was 8 kilometers per hour. Walked some other distance. Rate was 4 kilometers per hour. So notice that jog would be in kilometers, walking would be in kilometers, this would be in kilometers per hour, this is kilometers per hour. If we do all the flipping and multiplying and so forth, we will find that the kilometers drop out and we are left with hours back up in the numerator, which is the units we want. So that will work out for us. We'll rewrite this. We don't need the units until the very end. So we'll just write that as J plus W. I'll write this as 1 is equal to J divided by 8 plus w divided by 4. Now that we have our system, we can solve. Once again, I'm going to reach for substitution because I have this situation again where I have just coefficients that are 1. Now, I'm interested in j. So I'm going to be very strategic about this. If you don't see this right away, that's okay, because you will be able to back substitute and find it anyway. But if I solve for w, so I say 6 minus j equals w, I know that when I plug this in to the second equation, I will be replacing w with something in terms of j. Then I will have a single equation in the terms of the jogged distance, which is really what I am interested in. So I can eliminate w straight away by doing this substitution. So I will write that as w is 6 minus j, and then the next part of our algorithm tells us to plug it into the other equation. We do that, k over 8 plus, and this is 6 minus j over 4. I'm dealing with fractions here. When we're dealing with fractions, we're always looking for a least common denominator. Turns out that the least common denominator is 8. Now, I'm going to show you a trick. Maybe you've seen it before. It's called clearing the denominators. If we figure out what the least common denominator is for the entire equation, now this is 1 over 1, so 8 would work here too, we can multiply the entire equation by the least common denominator and see what happens when I do that. Okay, so I go 8 times 1, that's just 8. 8 times j divided by 8, pardon me. And then on this side it will be 8 times this quantity 6 minus j divided by 4. So this one cancels entirely and I'm just left with j. 8 divided by 4 is 2. And the fractions are gone. Yay. Now this looks like something we've solved before, so we distribute. 2 times 6, 12, that's a negative 2j. I will have negatives. We're comfortable with that at this point, I should hope. It does happen sometimes. Negative 2 plus 1, negative j. I'll subtract 12 from both sides. Negative 12 plus 8 is a negative 4. That gives me a negative j is equal to negative 4. And we know that we can simply flip the signs and have that we jogged 4, what are the units? Kilometers. We come back and check. Where are our equations? Here are our equations. We'll say step 4 is coming over here. We don't need to back substitute because I really don't care what w is. So I can skip straight forward and go to 4. So let's see. We will end up solving for w because we will have 6 minus, what did we say j was? 4 is 2. That comes from here. Now I'm going to put that number in this equation. We have 1 is equal to, we said j was 4, divided by 8, plus w divided by 4. Well, this is 1 is 1/2, plus w divided by 4. We're hoping to find that w comes out to be 2. If w comes out to be 2, then we are in good shape. I subtract half from both sides. 1 minus 1/2 is 1/2. That should be W divided by 4. If I multiply by 4 on both sides, I will have 4 times 1/2, 4 times W over 4, and I do get that 2 is equal to W. So in both cases, it checks, which means we are satisfied with our answer. And you could have done this another way. So we'll say Jamie jogged 4 kilometers.